Hello everyone, I hope you all doing well. In our last video, we learned about valency, what it is and how it help in writing chemical formula using criss-cross method. We also saw some examples like NaCl, water, aluminium oxide, etc. and understood how the combining capacity of element helps to form chemical compound. So today we will take a quick recap and explore how to find out valency and how to help valency in writing chemical formula. So if you have not watched the previous video, do check it out for a better understanding. So as we previously learned that an atom has positively charged nucleus. It contains proton and neutron. This nucleus is positively charged and the proton is positively charged, neutrons are neutral, and negatively charged electrons are revolving around the nucleus. These electrons are revolving around the nucleus in a fixed energy level. The electrons are, which are negatively charged, are revolving in a fixed energy level. These energy levels are called shells. So, the outermost shell of an atom is called valence shell, and the electron present in this shell is called valence electron. These electrons are deciding the valency of an atom. Let's quickly revise something very basic yet very important, the atomic number. What it is? The atomic number of every atom is the number of proton present in the nucleus of an atom. Or we can say that for a neutral atom, it also tells us the number of electron. So atomic number is the number of proton of an atom. I suggest you try to remember the atomic number at least up to 20 because they keep coming again and again. And when we write electronic configuration, find valency, or writing chemical formula, we need it. So I have already shared a simple table of element and their atomic number in my previous video. Do take a look and revise it regularly so that you can write the electronic configuration of every atom and find valency of any atom. So every atom tend to get stable. To achieve stability, some atom tend to lose electron or share electron or gain electron in its valence shell. So if any atom tend to lose its electron from the valence shell, then its valency is equal to the number of electrons lost by an atom. For example, sodium. Sodium has atomic number 11 and its electronic configuration will be 281. So there is one valence electron in its valence shell. To get stability, sodium tend to lose its valence electron, that is 1. Because it loses its electron, so sodium will get plus charge on it. So its valency will be 1. In case of magnesium, atomic number of magnesium is 12. So its electronic configuration will be 282. So there are two valence electron. To get stable, it tend to lose its all two electron. So its valency will be plus 2. Let's take another example like aluminium. Aluminium has atomic number 13 and its electronic configuration will be 283. There are 3 valence electron and to get stability it tend to lose all its 3 electron, and the valency will be plus 3. So if an atom tend to gain electron to get stability, then its valency is equal to the 8 minus electron in valence shell. Like in case of chlorine. Chlorine has atomic number 17. Its electronic configuration will be 2, 8, 7. So there are 7 electrons in the valence shell. To get stability, it tends to gain 1 electron in its outermost shell. So its valency will be minus 1. Or we can calculate its valency like 8 minus valence electron in the outermost shell. So 8 minus 7 is equal to 1. This is the another way you can find the valency of chlorine, or those atoms which tend to gain electron to get stability. Let's take another example. Oxygen. Oxygen has atomic number 8. Its electronic configuration will be 2, 6. So you can see there are 6 electrons in the outermost shell. So its valence electron are 6. These valence electrons are responsible for the valency of oxygen. So it tend to gain 2 electron to get stability. So its valency will be minus 2. If an atom tend to share its valence electron to achieve stability, then its valency is equal to the number of share electron by an atom. For example, in case of carbon, carbon has atomic number 6. So its valency will be 2, 4. So there are 4 electrons in the valence shell. And to get stability, it tend to share all its 4 electrons with other atom. So its valency will be 4 because it tend to share all its 4 electron with the other atom to get stability. So every atom try to achieve stable electronic configuration, that is follow octet rule. That means an atom tend to gain, lose or share electron to achieve 8 electron in their outermost shell, like noble gases. Because noble gases are naturally stable. Noble gases like helium, neon, argon, they all are naturally stable. And they are chemically unreactive. And every atom try to lose, gain or share electron to achieve same stable electronic configuration as the nearest noble gases called octet. So noble gases serve as the model of stability in the octet rule. Now that we understand why atom aim for a stable configuration like noble gases, now understand how they actually achieve it, and this brings us to the concept of valency. So it is the combining capacity of an atom. Combining capacity of any atom. It tells us how many electrons an atom can gain, lose or share to achieve stable octet. So here are 3 different types of atom which tend to get stable by losing, gaining or sharing its valence electron. First is electropositive atom. Second is electronegative atom. And third is covalent sharing. So those atoms which tend to lose its electron to complete octet, those atoms are called electropositive atoms. So its valency is equal to the number of electron lost, like sodium, magnesium, aluminium, potassium, etc. And some atom tend to gain electron to complete its octet. So its valency is equal to the number of electron gained in its valence shell. In its valence shell. And those atoms which tend to share its valence electron to get stability, its valency is equal to the number of electron share, like carbon and silicon. And the example of electronegative atom is oxygen, chlorine. These are the examples of electronegative atoms. So this is how we can calculate valency of any atom. Now we will get a quick recap of writing chemical formula. Write chemical formula. So we will follow few steps while writing a chemical formula. First, we will write symbol of element. In the first step, we need to write symbol of element. Now, write the valency below the symbol. Write valency below the symbol. So in the first step, you have to write the symbol of every element. Now next, write the valency of every element and then crisscross the valency. Crisscross the valency. Write the final formula without showing charges or valency. Now finally, write the formula. For example, if you want to write the chemical formula of magnesium chloride. So first, in the first step, as you have studied, in the first step, you have to write the symbol of element. So the symbol of magnesium is Mg and symbol of chlorine is Cl. Now we will write the valency of every element below it. So the valency of magnesium is 2 and the valency of chlorine is -1. Now crisscross the valencies and the formula that we will get of magnesium chloride is MgCl2. Now we will take the another example of aluminium oxide. Aluminium oxide. Now first we will write the symbol of element. Symbol of aluminium is Al and symbol of oxygen is O. Now write the valency of each element below it. So the valency of aluminium is +3 and the valency of oxygen is -2. Now crisscross the valencies and the final formula that we will get is Al2O3. But before write chemical formula, we must know the symbols and atomic number of elements. These help us to find valency, which is the key of making correct formula. I have already shared a table with atomic number and symbols of first 20 elements. That is very important. So if you have not seen it yet, do check that first so that this part become easier. Now, let's move on to the some practice questions to strengthen your understanding. Try to answer on your own before I explain pause the video, give it a try, and then play to check your answer. So, here is your first question. What is valency? Option A is number of proton in an atom. Option B is number of electron in the outermost shell. C is combining capacity of an atom. And D is atomic mass of an element. So as we previously studied that valency is the combining capacity of an atom. So the answer will be C. Next question is the valency of hydrogen is. The symbol of hydrogen is H and its atomic number is 1. So there is 1 electron in the outermost shell. To get stability, it loses its 1 electron. So its valency will be 1. So answer will be B. Next question is, what is the valency of oxygen? Symbol of oxygen is O and its atomic number is 8. So its electronic configuration will be 2, 6. As you can see, there are 6 electrons in the outermost shell. It tends to gain 2 electrons to get stability. So its valency will be -2. So the answer will be B. Next question is, an element with 2 electrons in its outermost shell will have a valency of. Suppose an element X has 2 electrons in its outermost shell. So it tend to lose its all 2 electron which is in the outermost shell to get stability. So its valency will be 2. So the answer will be A. Next question is, which of the following elements has zero valency? So here is the options: sodium, chlorine, neon and oxygen. So noble gases like helium, neon, argon, these noble gases are naturally stable. They are chemically unreactive. So because they are chemically unreactive, so its valency will be 0. They don't need to lose or gain electron to get stability. So its valency will be 0. So the answer will be neon. This is a noble gas. What is the valency of nitrogen? So nitrogen, the symbol of nitrogen is N and its atomic number is 7. So its electronic configuration is 2 and 5. So there are 5 electrons in the outermost shell. It needs 3 more electrons to complete its octet. So its valency will be 3. In some cases, nitrogen can also share its all 5 electrons, showing valency 5, like dinitrogen pentoxide. In case of N2O5, dinitrogen pentoxide, the valency of nitrogen is 5. So here, nitrogen has 2 valency depending on the chemical environment, 3 and 5. So here, both the answers can be right, A and B, because no particular compound has been given in this question. So both the answers can be correct. Next question is, if the valency of calcium is 2 and the chlorine is 1, the formula of the compound formed is. So symbol of calcium is Ca and the symbol of chlorine is Cl. The valency of calcium is 2 and the valency of chlorine is 1. Now crisscross the valencies and the final formula that we get is CaCl2. So the answer will be B. In next question, an element has 6 electrons in its outermost shell. Its valency will be. suppose there is an atom X which has 6 electrons in the outermost shell. That means there are 6 valence electrons. It tends to gain 2 electrons to complete its octet. So its valency will be 2. So the answer will be B. Next question is, valency of an atom is determined by, first is neutron, second option is proton, third is electron in outermost shell, and fourth is mass number. So as we know, valency of an atom is determined always by electron in outermost shell. So the answer will be C. Next question is, the valency of carbon is 4. What does it imply? So as we know, carbon has 4 valency. It tends to share its all 4 electron to get stability. Carbon neither gain nor lose electron because both option requires too much energy, which makes it unstable. Instead, it share electron to form a stable covalent bond. So carbon always share all its 4 electron to get stable electronic configuration. So the answer will be C. Next question is, what is the valency of magnesium? The symbol of magnesium is Mg. Its atomic number is 12. So its electronic configuration will be 282. So there are 2 electrons in the outermost shell. There are 2 valence electrons. And it tends to lose all its 2 electrons to get stable electronic configuration. So its valency will be plus 2. So the answer will be B. Next question is, which of the following elements show variable valency? So when an element show more than one valency in different compound, it is called variable valency. So some element can lose different number of electron depending on chemical environment, like iron, copper, tin, lead. So there are few elements which show variable valency. So here the option is sodium, calcium, iron and neon. So the answer will be C, iron. Next question is, noble gases have a valency of, as we previously read, noble gases have zero valency because they are chemically unreactive. They are naturally stable gases. They don't need to lose or gain or share electron to get stable electronic configuration. So its valency will be 0. The answer will be A. Next question is, which of the following has valency 3? Here's the option. Helium is a noble gas, so it has 0 valency. Next is aluminium, oxygen and hydrogen. So as we know, aluminium has atomic number 13 and its electronic configuration is 283. So there are 3 valence electron in its outermost shell which participate in bonding. So to get stable electronic configuration, aluminium loses all its 3 electron and get valency plus 3. So aluminium is the right answer. In case of oxygen, atomic number of oxygen is 8. So electronic configuration is 2, 6. So it tend to gain 2 electron to get a stable state. So its valency will be 2. In case of hydrogen, valency will be 1. So the answer will be aluminium. Moving to next question, which element is most likely to form an ion with +1 valency? So in case of So if we are talking about chlorine, it has -1 valency. Magnesium has +2 valency. Potassium and oxygen. Oxygen has -2 valency and potassium has +1 valency. So the answer will be C. Next question is, phosphorus has 5 electrons in its outermost shell. It, its usual valency is, so the symbol of phosphorus is P and its atomic number is 15. Its electronic configuration will be 285. So like nitrogen, phosphorus can share 3 or all 5 valence electron. So it show valency 3 as well as 5, depending on the chemical environment and depending on the compound. So here A and B, both the options are correct because no particular compound has been given in the above questions. Now the next question is, the compound formed by aluminium and oxygen is. So here we will use criss-cross method. First we will write the symbol of element, aluminium Al and oxygen O. Now write the valency below each element. So the valency of aluminium is 3 and valency of oxygen is 2. Now crisscross the valencies and the formula that we will get is Al2O3. So the answer will be C. Next question is, sodium has 1 electron in its outer shell. Its valency is. So as we know, sodium has atomic number 11. So its electronic configuration will be 281. So there are 1 electron and it tend to lose its 1 electron to get a stable electronic configuration. So its valency will be 1. The answer will be B. Next question is, what is the valency of sulfur in H2S? So as we have discussed that chemical formula can be formed by criss-cross method. So here H2S, sulfur will have 2 valency and hydrogen will have 1 valency. So the answer will be 2. Next question is, which of the following statements is false about valency? What the option says? Valency is always a fixed number. Next, some elements show variable valency. Yes, it is right that some elements show variable valency. Valency is based on outermost electron. Is it right? Yes, it's true that valency is based on outermost electron of element. Next is, valency help in writing chemical formula. Yes, it is also right that valency help in writing chemical formula. So the false statement, valency is always a fixed number. This is not true because few elements show variable valency. So it's not fixed. It is not a fixed number. So the option A is the right answer. Next is, in the compound calcium oxide CaO, the valency of calcium and oxygen are respectively. So here we will use criss-cross method and calcium, we will write the formula calcium oxide CaO. In this question, we will first write the atomic number of calcium, which is 20, and its electronic configuration will be 2882. So there are 2 electrons in the outermost shell and it tend to lose its 2 electron to get stability. Valency of calcium is +2 and in case of oxygen, electronic configuration will be 2 6 and it tend to gain 2 electron to get stability. So the valency of oxygen is -2. Now we will write the symbol of element and write the valency of each element below it, and now crisscross the valencies and we will get the formula CaO. Here We will simplify the subscript. So the valency of calcium and oxygen is 2. The answer will be C. The valency of calcium is 2 and the valency of oxygen is also 2. Now here is the last question. Which of the following element can show more than one valency? So as we previously studied, that few elements can show variable valency like iron, copper, tin, lead. So here the option given: sodium, calcium, copper and neon. So here C is the right answer. So that was all for today's practice question. I hope these helped you understand the concept better. If you still have any doubt, feel free to ask in comments or you can revisit the explanation part. Make sure to revise and try solving similar question on your own. In the next video, we will continue with new topic, so don't forget to join in. And if you found this helpful, do like, share and subscribe. See you in the next session. Bye bye.